Welcome to Systems 1.3. This is the third video in our Where Do Lines Meet set of lessons on solving systems of linear equations. You can find out more about this topic on our website, mathwarehouse.com/system, and we're going to mainly focus on using the substitution method today, plus a really cool free tool where you can check your work for any system of linear equations. Okay. By the end of today, you should be able to solve a system of linear equations like this using substitution. Prior videos have gone over what it means to solve a system, what a system is, so check back on the earlier videos if that's something you wonder. Like if you don't know what a system is or how to solve it, that's the first thing you should be thinking about. Okay, let's first look at some prerequisite knowledge here before we try to solve a system using substitution. So let's look at what's on the screen right here. Prereq. If I told you that x equals 5 and x plus y equals 8, and I wanted to know what is the value of y, you could probably really easily tell me, hey, obviously it's 3, right? Because 5 plus 3 is 8. But let's think about what you did mathematically. You actually used substitution. You know that x and 5 are the same thing, and you substituted the value of 5 in for x to get an equation like this. 5 plus y equals 8. You subtracted 5 from both sides to get the value of y equals 3. Now, we are going to apply the same idea. We're going to use substitution to solve a system of linear equations like this. Here we've got one line and we've got another line, and we want to know what are the values of x and y. Now, just like here, we said x and 5 are the same, so wherever I see an x, I can put a 5. Here I know that y and 2x plus 1 are the same. They are equal. Wherever I see a y, I can put a 2x plus 1, and that's exactly what I'm going to do. Notice, here's a y, so I'm going to take this 2x plus 1, and I'm going to substitute it in there to end up with x plus, I want to think about y as 2x plus 1 equals 10. And now let's simplify and see what that does for us. X plus 2x is 3x, plus 1 equals 10. Subtract 1 from both sides to get 3x equals 9. Divide both sides by 3 to get x equals 3. So, substitution was quite handy here. We were able to eliminate one of the variables. We were able to get rid of the y, get an equation all in terms of x. This is one equation, one unknown. Our x is unknown. And when you have one equation, one unknown, you can solve it. Now that we got the value for x, we're going to substitute again. We know that because we want to know what x and y is. We've got x is 3, and we want to know what the value of y is, so we can take x equals 3 and put it into either equation. I'll use this one. So y equals 2 times x, or 3, plus 1, y equals 7. Now, you will know that your solution is right if you can put x of 3 and y of 7 into any equation, into either equation, right? So x plus y equals 10. If you substitute the 3 and the 7 in, it works. And the same thing for substituting it in here. Y equals 2x plus 1. Right, so what's y? It's 7, and x is 3, and they both work. We double checked our answer. Life is great. So quick recap. Before you approach this topic, you should be familiar with what I did on the left. Simply substituting a value in for a variable, x equals 5. Put the x in there and solve it. Same idea for systems of linear equations. Difference being, we have two variables, an x and a y, and we are going to substitute an expression usually in for a variable, like 2x plus 1 in for the variable y. This allows us to get what I boxed in here, one equation with one variable, which can be solved. We're able to solve for x equals 3. Now, our solution is an x and a y value. So to get the y value, we just take this x of 3 and punch it into either equations, solve for y, and you can always double check your work like I did here by taking your x and your y values into both equations and making sure that they both work out. Okay, so let's try the same approach with another example. 2x minus y equals 2, and 3x plus 2y equals 38. Now, the idea with substitution is we want to be able to replace a y or an x with an expression. And it's not as straightforward as the prior example. But what we want to look for is, can we rewrite either equation as y equals some stuff or as x equals some stuff? Because if we can, then all we do is take wherever we see a y in the other equation and put the stuff. And you'll see what I mean by rewriting this top one here. Let's call this equation A on the top, B on the bottom. Let's rewrite A as, let's try to rewrite it as y equals stuff. Well, let's see. First off, let me rewrite it out here. 2x minus y equals 2. To get it to be y, it looks like it's going to be a little easier to get it to be y equals than x equals, because I noticed the 2 in front, and I'm like, this is almost already a 1y here. We've got a negative sign to deal with, but not too bad. So let's add y to both sides. Right, so you end up with 2x equals y plus 2. You could have taken the 2x over, but I chose to take the y over, so that we have 2x plus y equals 2. Now, to get it to be y equals, we have to get rid of this 2 here by subtracting 2 from both sides, giving us 2x minus 2 equals y. Now we're in this awesome situation where wherever I see a y, I can replace it with a 2x minus 2 because they are equal and the same. And that's what I'm going to do with equation B. Where I see this y, I'm going to put the 2x minus 2. So we'll end up with 3x plus 2 times, what's y? It's 2x minus 2 equals 38. And now that we've substituted, we just solve. We've got that awesome situation here where we have one variable, one equation, one variable, which we can solve for. So let's just simplify and solve for x. Don't forget to distribute out. 2 times 2 is 4x. 2 times negative 2 is minus 4 equals 38. 3x plus 4x is 7x. Minus 4 equals 38. Let's add 4 to both sides, so that we've got 7x equals 42. Divide both sides by 7 to get x equals 6. Alright, so now that we have our value for x, we can take that in and substitute again to get into either equation to get the y value. And I like this one because it looks a little easier. Equation A. 2 times x, or 6, minus y equals 2. 12 minus y equals 2. Let's subtract 12 from both sides, so that we get negative y equals negative 10. And multiply both sides by negative 1 to get y equals 10. And that's our solution. X equals 6, y equals 10. Okay, so let me recap the idea. When you're given two lines and you want to use substitution, you want to get your equation to be either y equals some stuff or x equals some stuff. And what I mean by stuff is what we did exactly here. We took equation A and we realized it wouldn't be too hard to say, to get it to look like y equals some x's and some numbers. We did that by adding y to both sides and solving for y. And right here we ended up with y equals 2x minus 2. Then what you do is you look at the other equation, b in our case, and wherever we see a y, we can replace it with 2x minus 2. Substitute it in to give us a single equation with one variable, and that's an equation that can be solved. Get your value for x, substitute it in to get the y. And that is substitution. Let's try one more example. Y equals x plus 2 and 3x plus 5y equals 10. This is another very straightforward example. We don't even need to do much because we already have our equation as y equals stuff. And that stuff is x plus 2. So wherever we see a y in the other equation, we're just going to take x plus 2. We're going to put it there so that we get 3x plus 5 times x plus 2 equals 10. That's 3x plus 5x plus 6 equals 10. 8x plus 6 combined with 3 and the 5x equals 10. Subtract 6 from both sides. Oh, whoops, made a silly error I see here. I said 5x, that was good, but 5 times 2 in the normal world of math is, alas, not 6. So let me take a few steps back here. Sorry about that. What we're going to go, we've got 3x plus 5 times x is 5x plus 5 times 2 is 10 equals 10. 3x plus 5x is 8x plus 10 equals 10. And subtract 10 from both sides, we've got 8x equals 0 or x equals 0. So now that we know that x equals 0, to get the y value of our solution, all we do is take that x and substitute it in. Y equals 0 plus 2 or 2. And that's it for substitution. Again, to use substitution, you want to get your equation in y equals a bunch of x's and numbers, or vice versa, x equals a bunch of y's and numbers. In our case, and in all of our examples, we made them y equals, as I was saying before, some stuff. And once you have that, once you have like y equals 2x minus 2, substitute 2x minus 2 in for y, or whatever your stuff is, in for that variable into the second equation. Solve for the second variable. That's your solution. Remember, you can always verify your answer by substituting the x and y into both equations. So let's end by looking at how meta-calculator.com can actually help you double check your work anytime you want to solve systems of linear equations. Just click on Scientific Calculator, hit Equation Solver, punch in your two equations. Let's look at 3x plus 5y equals 10 in this equation. Hit solve, and it'll tell you the solution is whatever your x and your y is. So definitely recommend meta-calculator.com's Scientific Calculator Equation Solver to help you double check any of your work. Very cool, free tool for that. Alright, that's it for using substitution. Check out the website if you'd like to see some interactive applets and worksheets with answer keys on this topic. Thanks a lot.